Hiya guys, welcome back to our podcast, Little Brains, Big Topics. Thank you for tuning in again, if you are tuning in again. Today we are talking about vaccination with regards to coronavirus once again. We felt like it was quite a big topic, right? And we wanted to talk about more elements of it because we felt like in the previous podcast, we didn't really get to touch upon vaccination, which is such a big topic right now. If you look at the media, everyone's saying, you know, we need a vaccine in the next 6 months, 12 months, 18 months to get things back to normal. Anything to add, Namati?
I think we need to be honest with our audience about what happened. I think that's what we're all about, right?
Okay, yeah, there's a reason we sound so down.
Basically, guys, we filmed an introduction, but then we realized we hadn't filmed it. So this is like our third take at it.
It's all Namati's fault.
It was my fault. Okay, I'm just gonna go through my points very quickly that I had on the sheet in front of me.
Yeah, it's all good.
Okay, so one of the things I learned from the podcast was, the reason we did the lockdown, it wasn't to prevent, it wasn't to stop the spread of corona. It was just to slow it down so the healthcare system can cope with it. So the number of people going in doesn't exceed the number of people coming out. So that's one of the things that I learned about. I didn't know about. Yeah, epidemics and power. Okay, this is what I told the chat. I was having a bit of brain failure, but essentially, so currently in America, I think they've made it free. If you have corona, they'll treat you for free. But if you have cancer, you're dying. They say, "Oh, you can die if you don't have healthcare." You say, "Oh, you can health insurance." They say, "Oh, you can die." So that's
they know free market health insurance, free market healthcare. It's a bad idea.
Terrible idea. Shout out to NHS.
NHS. I don't know how long we can shout out NHS, but hopefully for a good few more years.
Yeah, a few more Thursdays maybe.
A few more claps.
Yeah, a few more claps. But yeah, essentially, the point I was making, that the reason that we're fighting off corona, it's not necessarily to help people recover. It's a lot to do because of the fact that it can harm powerful people by it continuing the way it's continuing right now. That was one of my points.
Yeah, if you look at it, like, just to add to that, like, if you look at the detrimental effect it's had on the economy,
yeah, exactly.
In stocks like 2 months ago, and it was a really bad idea because everything's just plummeted. And they're saying so many people are going to be unemployed as a fallout from all of this coronavirus stuff. So it is really worrying. And that's why people are keen to get back to work as soon as possible.
Yeah. We'll see. Yeah. And as you'll see in the interview, we'll touch on economy as well and how that will impact, how it will go forward in the future.
Yeah, definitely.
A lot of interest. All right, yeah. So, guys, shall we? Have we told who our guest is?
No, we have not told who our guest is. So we'll do that now.
Let's go for it.
Today we're interviewing Professor Paul Allan Offit. And if his name sounds familiar, it's because he's quite a big deal in the vaccination industry. So Professor Offit, he's an American pediatrician, and he specializes in infectious disease, vaccines, immunology, and virology. But really importantly, he's the co-inventor of the rotavirus vaccine. So for those of you who don't know, rotavirus, it's one of the leading viral causes of diarrhea in young children, and he co-invented the vaccination against it. So as a result, probably saved hundreds of thousands of lives of young children across the world, which is quite substantial. He's currently working as a professor of pediatrics at the University of Pennsylvania. And he also in the past worked on the Center for Disease Control, the CDC, on the advisory committee, which is also very, very impressive. So he's got a great CV. He's also written some books. Interestingly and most noteworthy is probably his stance on the anti-vax movement. So he's a big supporter of, the opposite of a supporter. He's not supporting the anti-vax movement. He debunks the anti-vax movement.
The biggest opposer. There we go.
Opposer of the anti-vax movement. That's the one. So he's received lots of hate mail and death threats because he's kind of been debunking, this big movement we have against this big movement we have on anti-vaccination, especially in America. There's so many people who choose not to vaccinate their children. They say vaccination's not for me.
Originated from Britain, though. Andrew Wakefield. Yeah, Andrew Wakefield.
Oh, the study. Yeah, so there was a study that linked the MMR vaccine to autism. Very poor correlation. It shouldn't have been published, but it was. And as a result of that, conspiracy theorists in America, in the UK, all kicked off and they started saying, we're not going to get vaccinated. We're not going to get our children vaccinated. But Professor Offit, he's a big opposer to that. He wrote a book, The Anti-Vax Movement. So very, very interesting. And we talk about that a bit later on as well, how the anti-vax movement might influence the fight against coronavirus. Because even if a vaccine is made to achieve, any usefulness from it, you need a certain proportion of the population to get vaccinated. And if you've got all these people, I think a study from The Independent said it was 1 in 10 people in America are anti-vaccination for their children. I don't know how big the sample size was, but that's quite substantial. And it could influence the effect that mass vaccination programs are going to have. So it is quite worrying. Mm.
Yeah, and a couple of points we made in the previous versions. Just to, so it took Paul Offit 26 years to finish making of the rotavirus vaccine,
mm-hmm.
which is a long time if you think about it. And I was thinking he's probably saved the most lives out of anyone we've talked to in our lives. If you think about it,
that's crazy.
I'm just saying. I'm just putting it out there.
It's true. What a superhero! Very impressive work.
It's mad.
Mm-hmm.
And we get political at the end. By the way, guys, if you're into politics, watch out till the end.
A lot of politics to come. A lot
of politics to come. And hope you guys enjoy it. Mm-hmm. My tongue isn't working anymore. Let's just
get some sleep.
Yeah. We need. Me and Ashad desperately need some sleep.
We're quite sleep deprived. It's very important to stick to your natural circadian rhythm.
Yes.
You can wake with the sun, but we don't really tend to do that at this age. Not many of us do, to be honest.
Especially in the lockdown where we don't have any routines and we get to decide what time to sleep, what time to wake up.
Yeah, it's not the best way to be, but that's a topic for another day.
It's our next episode. Do we tell them what it's about? Right, it's about isolation. Mm-hmm. Watch out. Stay tuned, guys. We'll be talking about isolation.
Yeah, we will. But for now, anyway, without further ado, let's get on to the interview. And here is Professor Paul Offit.
Let's go, guys.
Thanks again, Professor Offit. So just to begin with then, would you mind introducing yourself and just kind of telling us about some of the projects you're currently involved in with regards to coronavirus?
Sure. So my name is Paul Offit. I'm a professor of pediatrics at Children's Hospital of Philadelphia and a professor of vaccinology at the University of Pennsylvania School of Medicine. I'm trained in pediatrics, but my professional career has mostly been involved in being part of a team at Children's Hospital of Philadelphia that essentially developed the rotavirus vaccine, RotaTech. That was a 26-year effort. Currently what I'm doing, I guess, regarding COVID-19 is I'm on the FDA's Vaccine Advisory Committee, the Food and Drug Administration's Vaccine Advisory Committee. I'm also part of a team at NIH that's doing what it can to try and accelerate vaccine development.
Sounds very interesting. So yeah, we want to ask a lot more about kind of the stuff you're doing with vaccines, and specifically with regards to corona, obviously. But before we do, we have some kind of generic questions as well that we want to ask. So yeah. I'll hand it over to Mohammed to ask some of those initially.
Yeah, there is our audience are a broad range of people from all. So we want to start off from the basics. So could you tell us what is a vaccine and what are different types of vaccines that we have?
Okay, so the purpose of a vaccine is to induce an immune response similar to natural infection without having to pay the price of natural infection, which can be brutal, like suffering, hospitalization, permanent harm, death. So the goal is to get the immunity without paying the price. There are a number of different strategies for how to do that. In the world of viruses, like COVID-19 is a virus, you can take the virus and kill it, which is the way that the polio vaccine is made. That's the way the rabies vaccine is made. You can take a virus and weaken it, which is the way the measles vaccine is made. The mumps vaccine, the German measles vaccine, the chickenpox vaccine are all weakened live viruses. You can take part of the virus. In this case, it would be the surface protein of the virus, because that's the protein that allows the virus to attach to cells and infect cells. So if you can keep that protein, if you can neutralize that protein, then the virus can't attach. That's the way that the hepatitis B vaccine is made. That's the way the human papillomavirus, or HPV vaccine, is made. You can take a so-called vectored approach, which is to say you take a sort of weakened virus into which you then clone the gene that you're interested in this case codes for that surface protein, which is the way the Ebola vaccine is made and the way the current dengue vaccine is made. Or you can try a genetic approach for which there are no current vaccines. So you can take messenger RNA, which is then translated to this protein that you're interested in, or you can take DNA, which is then transcribed to messenger RNA, which is then translated to a protein, all of which is sort of the same thing as hepatitis B or HPV vaccines. It's a single protein vaccine, essentially, just delivered by a different route. So those are really the 5 strategies.
That's very interesting. So with regards to those strategies then, what's kind of the different stage that you have in developing the vaccine for a given disease?
Right. Well, just to give this a heads up, I mean, it did take us 26 years for us to make the rotavirus vaccine, and that's typical. I'd say a 20 to 25-year program is typical. So when Dr. Fauci and others stand up in front of the American public and say, we're hoping to make this in 12 to 18 months, that's amazingly, amazingly fast. Because here's the way that you do it. First, you have to decide what of those 5 approaches you want to try. Because one may work better than the other. So we're not even at the point where we have that approach yet. I mean, we just recently found out about this virus a few months ago, so we just now have the virus in hand. Once you decide on what approach you're going to use, then you try and do initially, hopefully, animal model studies, where you have an animal, like a mouse or a rat, you infect it with coronavirus, this COVID-19, and then hopefully the animal gets pneumonia, say. Oh. So now you have an animal model to study whether or not your vaccine idea works. So you give the animal model your vaccine, and then you challenge it later with the virus that will cause pneumonia. And if it prevents pneumonia, then you can say, okay, it looks like my proof of concept works. That takes usually years, just to put that in perspective. Does the animal model work? Usually takes years. You can skip that if you wanted, although I personally think you should never skip the animal model approach, but something we did. But then you go to sort of so-called phase 1, phase 2 trials, which is you do sort of progressively larger safety and immunogenicity trials. So you give your vaccine, you want to make sure it's safe, that's the key thing, and then you want to see what kind of immune response it evokes. But you don't know whether that immune response really is protective. You don't know that. You can see that they have an immune response, but that doesn't necessarily mean that people are protected against disease. So then you ultimately have to do a big efficacy trial, safety efficacy trial, so-called phase 3 trial. For our vaccine, that was 70,000 infants. For another rotavirus vaccine, that was 60,000 infants. For the human papillomavirus vaccine, that was 30,000 people, mostly women, as part of a 7-year clinical trial. Once you've done that, assuming it works, and I imagine it would be done in healthcare workers because they're the ones most likely to confront this virus, you have to hope that there's, well, hope is maybe not the right word, but you would have to hope that there's enough disease out there that you don't have to do tens of thousands of people. Because if there's not a lot of disease out there, you have to have enough people on both sides so that you can see that, say, there's 17 cases of disease in this group, but no cases of disease in this group, therefore I can say that it works. But there has to be a lot of cases out there. I mean, right now, less than 2% of the United States population is infected. So you have to hope there's more disease out there that you can see whether your trial works. Now you've got something you think can work. You have to scale it up. You have to make sure you have the right buffering agent, the right stabilizing agent, the right vial. You have to do real-time stability studies. And scale up itself is hard. I mean, you're making vaccine here for tens of millions or hundreds of millions of people. And so, because this vaccine would be given to mostly the healthy people who would not normally die from this virus. I mean, the virus tends to really kill people who are over 65 who have other health problems. You better make sure it's as safe as you can make sure, as you can tell before you give it to millions of people. So I think optimistically, honestly, if everything worked perfectly for this vaccine, I think it could be available in 5 years. The notion that it could be available in a year and a half or 2 years is just remarkable to me. I guess we'll see how it plays out, but it is remarkable. The fastest vaccine ever developed was the mumps vaccine, which was, they had the virus in 1963. That was a commercial product in 1967, 4 years. And that was in the 1960s, before the Food and Drug Administration had much higher regulatory burdens. So we'll see how it plays out. But I think it's mechanics, as I think our President Trump said, hopefully we'll get a vaccine in 2 months. I don't know what planet he was living on when he said that, but that's what he said.
We will get to Trump in our future questions.
Yeah, we have a lot to ask about Donald Trump's actions in recent.
So this question is a bit dumb question, but I felt like I need to ask it. So since you co-invented the rotavirus vaccine, is there a Eureka moment when you're developing a vaccine? No.
It's more like sort of 2 steps forward, 1 step back. It's sort of moments of anxiety interspersed with moments of boredom. That's pretty much the way science works. I mean, you go from sort of one failed experiment to the next with unabashed enthusiasm. I mean, nature gives itself up to you very slowly. I mean, you think you have it, you think you're good, and then something pops up that isn't exactly what you expected. And so it's back to the drawing board. And that happens over and over and over again. You have to be a real optimist to be a scientist, because there's a lot of failure in the process. So and you don't really think you're making a vaccine. I mean, we were just trying to understand the virus. I mean, the first paragraph of our grants always said bad disease, need to make a vaccine, but you never really think you're making one. You're just trying to figure this all out, and then you create strains that you think could be a vaccine, but even then you don't think you're making a vaccine. Then you go to a pharmaceutical company and say, hey, would you like to try and see if you can make this a vaccine? Because they're the only ones that have the resources and expertise to do that. I mean, that trial that I told you, the phase 3 trial for us, which was, a 70,000 child prospective placebo-controlled 4-year, 11-country trial, that was a $350 million study as a single clinical trial. The whole program was maybe $1.2 to $1.5 billion, and that was, one program by one company. This would be much more expensive, not because we knew a lot more going into our program than this program does. The good news is there's a lot of interest in making a vaccine. There's more than 40 companies across the globe that are interested in doing this. So there'll certainly be a tremendous effort for doing it. My only concern in this is there's such panic out there. I mean, such terror about this virus that we may feel like we should cut corners to get to the prize, and that's never a good thing.
Yeah, I can imagine that could not end so well if you are cutting the corners and taking out the safety measures.
Yeah. Well, actually, I think I'll ask one of the questions I plan to ask in later. I'll ask it now because it relates nicely. So yeah, as you said, it takes around 20 years to develop a vaccine. So how worried are you about the fact that people are saying it will be able to do it in a year or 18 months? Do you think they're just being too optimistic, or do you think they will they won't do like all the stages properly, which will have its own consequences?
Well, I mean, sure. Yes, I do worry about that. I mean, I'm on the FDA's vaccine advisory panel. I mean, technically, that I can't imagine this vaccine would be sold to the general public without FDA licensure. Right. I mean, I'm on the licensing committee, so hopefully we'll all get a chance to look at it before licensure, and we either recommend it or don't recommend it based on safety and efficacy data. So hopefully they won't try and bypass the FDA. It's possible they could do that. There's something called the Emergency Use Authorization Act where you can bypass the FDA. I hope we don't do that, but we'll see how this plays out. Yeah, sure, I worry that things could be done that quickly. It's just not possible to do it that quickly. I honestly don't see how it is possible to do it that quickly and know that you have a product that is clearly safe and clearly effective. I don't see how you can do that in a year and a half. We don't even know what strategy you're going to use yet.
Wow. And that's what the newspapers don't tell you, by the way. Most research I've done, like when they talk to like their estimates, they don't go more than 2 years. Like when I read papers. So could you tell us about coronavirus in general, and what makes SARS-CoV-2 type, which is what's causing the current pandemic, so dangerous as opposed to other strands?
Okay, so in the early 1960s, human coronaviruses were first identified. In the United States, there's 4 strains that circulate of human coronavirus, and every year, I would say 15 to 20% of the respiratory illnesses that come into our hospital are caused by one of these or other of these human coronavirus strains. A few years ago, there emerged from Southeast Asia SARS, severe acute respiratory syndrome. That was 50% bat coronavirus. I mean, the Chinese have a taste for bats. They drink bat soup, they drink bat tea, they eat fried bats. So there's a connection between animals or bats and humans in China. And so that virus emerged. Now, it caused, worldwide, it caused 8,000 cases and about 800 deaths at a 10% mortality rate. But if you got SARS, you were sick. So it was very easy to tell who was infected and who wasn't. Then, emerging from Saudi Arabia was MERS, Middle Eastern Respiratory Syndrome, another novel coronavirus, another coronavirus nobody had ever seen before. That was partly a camel coronavirus, because mammals have their own sort of strands of coronavirus. That caused about 2,500 cases in the world and 1,000 deaths. Those were both one and done. They were 1-year phenomena, then they were done, and they never came back, even though certainly most of the world's population is still susceptible to both of those viruses. They came and went. Then came this virus, which so far has caused, hundreds of thousands of deaths in the world, and in the United States, as of this morning, about 32,000 deaths, and UK also we're all suffering, every country suffering. This virus is different in that 80% of the people who are infected either have no symptoms or very mild symptoms. That wasn't true of either SARS or MERS. So this is much more easily transmitted. You can come in contact with someone who has no symptoms, but is still shedding the virus and therefore can still be contagious to you. That's what makes it so frightening. I think that's why people are so scared. I mean, smallpox was a frightening disease, but there was no such thing as asymptomatic smallpox. Everybody who had smallpox was sick, and you could tell they were sick because they had, the blisters on their face. So you knew who was sick. This virus, it's like AIDS in a sense. I mean, the reaction to it is the same as AIDS. When AIDS sort of came into this country in the early 1980s, nobody knew what caused it. Nobody knew how you caught it. And so everybody was frightened. They were scared to pick up a piece of food in the grocery store. And that's what this is like. I mean, because there's fomite spread, meaning, that you're told to constantly wash your hands because you may touch a handrail or an ATM machine or something else where that virus is living. That's what makes people so scared. It's just, they're not sure how they might get it, or they're not quite sure how to avoid it.
Right. That's very interesting. So kind of tied into that then, I wanted to ask, with regards to these viruses and, there's different mutant forms of coronavirus, which they have this potential to cause more pandemics. Is it possible within a lab to kind of preempt the production of, a mutant form of a virus and vaccinate against it? Is that something that is possible?
Well, so this is a novel virus. It came up in China. It was unexpected, as SARS and MERS were unexpected. But I think you're right. I think this is not the last of this. But it's often true that the viruses or bacteria we're infected with come from animals. There are adaptations from animals. I mean, tuberculosis, for example, really came initially from cows. I mean, it's sort of a mutant sort of tuberculosis from cows. The AIDS, which we just talked about, human immunodeficiency virus, was originally simian immunodeficiency virus that probably to some hunter, killing a monkey in the Cameroons, cut himself, and then he entered his blood. So ultimately that virus mutated from simian immunodeficiency virus to human immunodeficiency virus, rotaviruses or animal viruses. So I think, we're constantly sort of getting these viruses that spill over essentially from animals. So is it predictable? Not so predictable. What bothers me about this, though, is that China could have certainly been a better actor here. I mean, we shouldn't have had to depend on a whistleblower to tell us that there was suddenly a virus spreading through Wuhan that was killing people. I mean, that should have been made quickly available to everyone so that we could begin to prepare. I mean, our country certainly knew about the serious nature of this by mid-January, and we still were very slow to react.
Was it 6 weeks, the period China didn't reveal that? Was it 6 weeks too late when they first initially said it?
It's hard to know. I mean, they are a little bit of a black box. I'm not sure exactly when those first cases were. I mean, we had to depend on the whistleblower to tell us things were bad. That virus could have started as early as October before that.
And aren't you surprised that sort of the counterintelligence agencies didn't find out about it? Sort of, or they didn't warn, because I think there was reports that they were trying to warn the White House beforehand.
The intelligence agency first warned the White House around December, and then they went to Congress by mid-January and said, this is going to be a problem. This is a pandemic in the making. React. And we still were slow to react.
So if it had all come out earlier, do you think it could have been contained in a similar way to MERS or SARS? Or do you think just the asymptomatic nature of it would have led to it inevitably becoming a pandemic?
Yeah, it's once the virus came in the country, you were in trouble. Once there was community spread from one person to the next, you were in trouble. Now the Pandora's box had been opened and you were in trouble. I mean, you could have certainly lessened the burden by really restricting travel from Asia when this was a problem, and restricting travel from Europe when clearly this was a problem in France and Spain and Italy. We were slow to do that. I think that's why New York got hit so hard. I think that people came from those three countries I just mentioned, came in from LaGuardia or JFK and spread that virus very quickly to the New York population, and they were overwhelmed. I mean, half the deaths in this country are from New York City and New York State.
Yeah, that's insane.
So my next question was sort of about because so as someone who's electronics engineer, I don't know much about viruses. So I was wondering, like, if you look at a virus under a microscope, will you be able to tell how it's going to manifest itself inside the human body?
No.
Oh. Right.
The sequence of the virus, which we know the sequence of this virus. That doesn't tell you how it's going to manifest itself in the human body either.
You just have to watch to see. Right. Fair enough. So you can't really sort of, people are like conspiracy theory people are saying, oh, like it was created in a lab. You can't really say, okay, I want to make a virus that does that. You can't really make it. Right? If you're making a new virus.
Not for this virus. Yeah, this is a novel virus. So I think what you could do is you could try and figure out a way to take smallpox and then make it so that it's transmitted by the respiratory route, or easily. Well, it's transmitted, but make it much more easily, make it more like measles. You probably could, which is much more contagious. Or you could take a virus like rabies, for example, which is only, really contracted by the bite of an animal, and try and make that spread by the respiratory route. That would be bad, which was really the movie Contagion. That was that movie. I never saw the movie Contagion, but like a rabies-like virus that was transmitted by the respiratory route, that's a problem, because this is like a universally fatal disease.
That's interesting.
And do we? So I read some Guardian articles. I read was saying that we don't exactly know what happens inside a person when they get corona. So sort of, I read this word called cytokine. Yeah, what was it?
Cytokine storm.
Yeah. Oh, yeah. So how does that work? Like, what's happening? What happens inside the person once they get infected with corona?
Yeah. So usually the virus reproduces itself in the upper respiratory tract, then it spreads down to the lower respiratory tract, the lungs, where it can cause a viral pneumonia. Right. Sometimes, in addition to just the viral pneumonia, that the virus destroys cells, that the virus induces this kind of aberrant immune response. So cytokines are part of your immune response, probably the principal cytokine associated with this syndrome, otherwise known as acute respiratory syndrome or respiratory disease, ARDS, or acute respiratory disease syndrome, or cytokine storm, is a cytokine called interleukin-6. So yeah, I mean, that happens. It's interesting that when you die from viral or bacterial infections, it's usually your immune system that kills you. Not so much the virus or bacteria per se, it's your immune response to the virus or bacteria. begging the question, why would your immune system kill you? And I think probably the sort of teleological reason is that you're given a chance to get better from your infection. And if you don't, then you're basically culled from the herd. So sort of from a societal standpoint, because you're now shedding a lot of virus, excreting a lot of virus, it's better for the herd that you're taken out. So your body pretty much kills you. Your immune system kills you.
And so how is it that in older people that's more likely? Because wouldn't they have like fewer white blood cells? So I don't know. I'm just.
Well, so it's not really the kind of cells that make interleukin-6 are usually macrophages, sort of these professional antigen-presenting cells. So it just happens to some people and doesn't happen to others. The good news is there's a monoclonal antibody directed against interleukin-6 called tocilizumab. So you can treat people often successfully with that, with cytokine storm.
So the next thing I kind of wanted to ask you was, obviously there is this big global push to try and produce a vaccine, and you said yourself that it would take up to 5 years realistically. Do you think that without a vaccine there's a possibility of us getting back to normal day-to-day life, or is the focus really on developing this vaccine as soon as possible?
If we're waiting for a vaccine to get back to the routine, we're going to be waiting for a while. I mean, that's I mean, Dr. Fauci, who's the head of the National Institute of Allergy and Infectious Diseases, said that we're not going to have any large-scale sporting events until there's a vaccine. What? I mean, first of all, I'm a Philadelphia Eagles season ticket holder. This is painful.
Get a refund.
I don't think you get a refund, do you? Because it's like natural disaster, right?
I would hope so. I mean, see, also, frankly, the players shouldn't be paid either, if they're not playing. But
oh man,
it's your question 11, Asha.
Yeah, so I was going to ask then. Do you think it's possible to totally eradicate COVID-19, or will it become an endemic?
Don't know. I think we'll learn as we go here. The human coronaviruses are usually winter-spring viruses. They go away in the summer. The reason is they're spread by small droplet, that when it gets more humid out, those small droplets tend to take on water and drop more quickly. So therefore you become less contagious. I don't know whether that's going to happen with this virus. I mean, like in Greece, for example, they don't seem to be suffering as much as their northern neighbors. That's a good sign. Maybe it's because it's more humid and hotter in Greece. I hope that's it, because we're about to enter summer here. But that may not be true. I mean, this is a bat coronavirus that's just made its debut in the human population. I don't think anybody really knows how it's going to act. Maybe it'll go through the summer. Maybe it'll be here next year and the year after and the year after. I tend to think it will fade over time, much as SARS and MERS did. But again, we'll have to see. But if we're waiting for a vaccine to go back to work, that is painful. I think the goal, as I understood it, the way it was initially explained, was flatten the curve, right? I mean, make sure you don't overwhelm the healthcare system. Make sure that, we can take care of these patients and that we can take care of other patients who need acute or intensive care. Make sure you can do that. And we're there. We're already there. I mean, hospital discharges are already much greater than admissions. A lot of these ICUs are vacant. We're not doing elective surgery, so that also doesn't burden the ICU. We have plenty of ventilators. As far as I'm concerned, I think we can start going back to work, slowly going back to work. And maybe there will be a bump in cases and a bump in deaths. But if the goal is to have nobody else dying from COVID-19, then we should stay in our house for the next 2 to 3 years. I mean, it's just not going to happen. Yeah. And every year influenza in this country kills 35, 40,000 people. Once we started to shelter in place or lock down, whatever, the incidence of flu also dropped more quickly than it would have normally. So great. So let's stay inside every winter and avoid the 35,000, 40,000 deaths from influenza. We can't do that. I mean, life is risk. Also, there's been fewer car accidents, people dying in car accidents, because no one's driving. So that's another reason to not ever go outside. I mean, we're going to at some point have to go back to work, because now we're about to experience the second part of this major public health disaster, which is joblessness. We already have 22 million Americans that have applied for unemployment insurance, and those are the ones, one, who could figure out how to do it, and two, who could do it. Because, there are a lot of people who are have illegally entered this country, who work in this country, who can apply for unemployment insurance. You're going to have 35 million Americans unemployed. At least that's 20% of the workforce. I mean, we are mimicking what happened in the Great Depression in the late 1920s. And with that level of joblessness comes homelessness, and then all the things that come with homelessness: food insecurity, drug addiction, increased domestic violence, child abuse, suicides. That's round two. So I think we need to start thinking about how to get back to work to avoid the tragedy that's the second tragedy that's about to come with this.
Wow. And if it, in the case it becomes an endemic, will it be worse than the seasonal flu, or will it be just another thing we're watching out for, or will it be like a uniquely disturbing fact of the world if it becomes an endemic?
If it becomes endemic, like flu, so there's seasonal flu every year, which kills 35 or 40,000 people. I'd be surprised if this virus did that. I mean, the problem with flu is it's a moving target. I mean, that virus mutates so much from one year to the next that natural infection or immunization the previous year doesn't protect you the following year. This is not that virus. I mean, it wasn't SARS, it wasn't MERS. This is not a virus that mutates. I mean, it's a single-stranded RNA virus, so it's always going to have some mutations, but it doesn't look like those mutations appear to either affect function or appear to make it so that a vaccine wouldn't be able to consistently work. I mean, there are other single-stranded RNA viruses that are stable enough, like measles or mumps or German measles. Those are single serotype viruses, so I think that would also be true here.
Are you concerned about our ability to mass produce the eventual corona vaccine and whether or not the distribution will be fair? And that's kind of assuming we'll be able to get it in the time frame that they're telling us, which you already don't agree we will be able to. But do you think if we manage to, like very optimistically, we manage to get it in 18 months, it's produced, we got it. Do you think we'll be able to mass produce it on a global scale? And if so, will the distribution be fair? So won't we have the poorest countries who need it the most being the least likely to get it? Because all the rich countries.
The first question is: are the poorest countries the ones who would need it the most? I mean, it depends on what the spread is of virus in those countries. I mean, I think that you would distribute it to the people to the countries that are most suffering, to the people in those countries who are most likely to suffer, which is frontline responders like healthcare workers and medical transporters, etc. And then it depends, and certainly people who are associated with nursing homes. And what's interesting about this virus is that most of the deaths are really in those who are over 65 years of age who have other comorbidities like high blood pressure and type 2 diabetes and obesity. I mean, this virus, it's like as many as half the deaths occur in those groups. So you know who this virus is. So that's not flu. I mean, flu, for example, in this country, of the 32,000 or so deaths, fewer than 5 deaths have been in children, whereas 155 children have died of influenza this year. So it tends to spare the young and the healthy. It's the older people who need to be protected, assuming that, you think people as old as me should still be allowed to live. I think we should still be allowed to live. But, but there was an old movie called Wild in the Streets. This is before your time. Max Frost. Take a look. It's Wild in the Streets. It's when sort of everybody over 30 had to be killed. This new to you?
Wow. I think I've heard something about this. It rings a bell. Was it basically an ageist Thanos? Yes. It sounds like.
There was a song that was very popular. There was like "Nothing Can Change the Shape of Things to Come" or something. Max Frost, I think, was the name of the guy. Take a look. I remember thinking at the time I was, in my late teens, early 20s, so I wasn't worried then. But I'm worried now that guy.
So we think so. Our next question is. So please do feel free to tell if you can't answer it. We don't want you to lose your job if that because you work in it. So what do you think of Trump's decision to halt funding of the World Health Organization? Are you allowed to answer that?
Yeah, sure. We're still firing me, right? I'll come to lead.
Yeah, perfect.
I think that it's wrong at so many levels. First of all, he chooses to try and find a scapegoat, right? Because he can never take blame on himself. He cannot take blame for the fact that we were very slow to develop testing, or take blame for the fact that he already dissembled a pandemic preparedness plan that had been put in place in 2005, or take blame for the fact that he was slow really to allow people coming in from countries where this was problematic. So he chooses to blame people. This is his defining characteristic. Finger pointing. So he says the World Health Organization failed in its responsibility to alert the world to what was going on. But the truth was, we certainly had information as early as mid-December that there was a problem, and had credible information presented to Congress by mid-January. So that's wrong. Secondly, it's not like the World Health Organization only works on COVID. I mean, they work on malaria, they work on rotavirus, they work on a variety of illnesses that hurt and kill people in this world, and we are a player we used to be a player in this world till we had this big America First theme, which is really just basically selfishness and not doing the part that we should be doing in this world. I think it's awful. And I think, in a better world, the other congressmen, senators would stand up and say how awful this was, but they don't do it. I mean, he acts like a king because he can, because we let him get away with it.
Mm. It's annoying.
And I bet he recently discovered he could do that. Like, I bet he just found out, like, as soon as he found out it was within his power to halt it,
I'll stop now. Yeah, staying on the theme of kind of politics, I wanted to ask as well, from what we understand, Professor, you're quite interested in the anti-vax movement, and you have a fascination with people who, abstain from vaccinating their children, and you've written a book, I believe, about the anti-vax movement. So we just want to understand a bit better, why is it that so many people, and it seems like a lot of people in America especially, choose to, abstain from being vaccinated themselves or getting their children vaccinated? What's kind of going through their head?
Well, so I think there's two groups. The most common group is what I would call sort of the vaccine hesitant parent. They, we ask parents in this country to give their children vaccines in the first few years of life that prevent 14 different diseases. That can mean as many as 26 inoculations during that time. It can mean as many as 5 shots at one time to prevent diseases that most people don't see, using biological fluids most people don't understand. So I think it's not surprising that there's pushback. People say, why do I need a polio vaccine? We haven't had polio in this country in decades. Why do I need a diphtheria vaccine? It's so uncommon, or a tetanus vaccine. Why do I need those vaccines? And why do my kids have to get so many shots? So I think, for people like me who experienced all these diseases, I was a child of the 50s. I had measles, I had mumps, I had German measles, I had chickenpox, I had all those diseases. Wow. I remember what they felt like. I certainly grew up in medicine with a lot of these diseases. I was in a polio ward when I was 5 years old. I remember these diseases. I think, most young parents, and frankly, most young doctors and nurses never grew up with these diseases. They don't see them today, so they're less powerful advocates. That's one group. I think the anti-vaccine activists, what I mean by anti-vaccine activists, are conspiracy theorists. Mm. They believe that the pharmaceutical companies control everything. They believe the government is in the pocket of the pharmaceutical industry. They believe that the medical establishment is in the pocket of the pharmaceutical industry, and that they're always being lied to. So when you, for example, I wrote a book called Autism's False Prophets, which basically just said that vaccines don't cause autism. By the way, thank you for Andrew Wakefield. Really, thanks for sending him here. Andrew Wakefield was a British gastroenterological surgeon who came up with the notion that MMR vaccine caused autism, which created it in England. And then, so first it was the T-tax, and now it's Andrew Wakefield. It's all bad.
Do you know how many people he's responsible for killing? That single article.
Well, yeah, I think that article killed children. I absolutely think that's right. And in England, when that article was published, there were thousands of parents who chose not to give their children that vaccine. There were hundreds of children who were hospitalized. There were 4 children who died. 4 children who died. I think you could argue that article killed children. And I blame not just Andrew Wakefield. I blame his co-authors. I blame the journal for publishing it. I blame the media who quickly jumped all over this article. And I think academics were slow to react to this. I think there's a lot of people to blame. By the way, just so you'll love this, right? So I had a book that came out 2 days ago by HarperCollins. It's actually also being published in England by Scribe. Is that a familiar name? But in any case, it's called Overkill When Modern Medicine Goes Too Far. Yes. So, see, I think it's smart to launch a book when there's not a single bookstore in America that's open. Don't you think that's a good time?
Yeah. Amazon is taking over. Don't worry.
Yeah.
We'll be all fine.
Yeah, kind of related to what you just said as well. So you said that there's a group of people who, they just conspiracy theorists, and I can imagine when you're that set in your mind about something being a conspiracy, it's very hard to change your perception on things. Do you think that in the future, when the vaccine does come out, is that group of people substantial enough to kind of jeopardize the mass vaccination program with coronavirus, for example?
It'd be interesting to see. Were this virus still as potent then as it is now? Was it still, if it was still, people were scared to walk out of their house, scared to shake anybody's hand, scared to come within 6 feet of anybody else because of fear of getting the COVID-19. I'm sure they're scared of getting this virus as everybody else. Would they then choose to be vaccinated with the data that were available, which, will be thousands of people, but not millions of people? Would they be willing to get a vaccine? We'll see just how serious they are about this. My personal bias is I think they probably would. I think their problem really has to do with mandating vaccines. They don't like to be forced to get a vaccine. They always like to see this as an issue of choice. Although I think were this vaccine to be available and the disease was still as bad as it now, I think it would be a mandated vaccine. I think people would say it's not your right to catch or allow your child to catch and transmit a potentially fatal illness. Sorry, you have to be vaccinated. I think that would happen, which that's what would piss them off.
And
yeah,
demographically speaking, are they more tend to be on right-leaning people or left-leaning people who are in the vaccine denial movement?
Both. On the right side, it tends to be sort of the libertarian, government off my back, don't tell me what to do, the sort of Rand Paul argument. Here in the United States. On the left, it's this sort of crunchy granola, bib overall, all things natural. I don't want to be injected with a foreign substance crowd.
Right,
so there's not politics to this. It's left and right.
The same as like the anti-GMO people, I guess. The same. Okay. I see. So related to all of these, do you think there is a resurgence of science denialism in general? Like Flat Earth Society being a blatant example. Do you think that, and if yes, what do you think is causing it?
Yes, is the short answer. I think we've always at some level been scientifically illiterate, but at least, there was a certain respect for expertise and experience.
Yeah.
That's changed. I think the internet is part of it. That, you feel that you too can become an expert by simply Googling the word vaccines. But that's not true of all things. I think, like, for example, if you're about to have a gallbladder operation, I don't think you're going to go on the internet and look at how one does a gallbladder operation and then disagree with your surgeon about what his or her approach is. Similarly, with mechanics, you go take your car in because it needs to be repaired. I think you're not probably arguing with your mechanic about what the best way to do that is. What the hell do you do? But that's not true for vaccines for whatever reason. I think it is. Do I think a scientific denialist? Yes, I think our president is a scientific denialist. He said during one of the presidential debates he thinks vaccines cause autism. Our Secretary of the Department of Education is a creationist. So is our Vice President. I think, you now have an environmental protection agency which was forced to take the phrase climate change off of their website. It's beyond scientific denialism. It's just, it couldn't be worse. So I think when it is scientific denialism, then educating people doesn't help. Literacy, in theory, you can educate, sort of the deficit model. But if people just declare their own truths, you're sort of stuck. People feel that they're all experts, that they can know just as much as you do by going onto the internet for 15 minutes.
This is true. This is very true.
Wow. It's a side effect of internet in general, the same way smart people can gather well, not stupid people, but people with otherwise, let's say, rare views can find each other and create cults and sort of
communities.
Communities would be a better word. And advanced, for example, if you decide to, create a YouTube channel, your voice will be just as strong as someone, a random anti-vaccine person. So is that sort of because it's given everyone equal voice in some sense? That's what.
Yeah, definitely. Yeah, they're the mouse that roared. I mean, they certainly make up, I'm sure, well less than 1% of the population in the United States, but they're the mouse that roared. And also, it's easier to find like-minded people who have similar, ill-conceived notions on the internet. So you can, whereas before it was being harder to do that. And you're right. I mean, in the old days when it was just sort of newspapers and radios, magazines, where they were much more responsible, there was actually sort of a journalistic standard. There is no journalistic standard on the internet.
Yeah. There was a level of filter between the people and what gets published to the public. There was
Levels removed.
So would you like to tell us? So what date did you say your new book is going to be published in the UK?
I'm not sure. I know that I signed a contract with Scribe, and so presumably soon. But I think you can probably still get it off the internet there. I mean, it's off. If you can order it on Amazon. So.
Right. And would you like to tell us what themes you cover in the book?
Sure. But here's my dog.
Oh yeah. Oh, perfect. Yes. We're going to put pictures of the book. We're going to put pictures on the screen as well for people. Links in the description. Everything.
So the book's called Overkill When Modern Medicine Goes Too Far. It's sort of those situations in modern medicine where there's abundant scientific evidence that we shouldn't be doing something, but we do it anyway. So, for example, treating fever. You shouldn't treat fever. I mean, we all make fever. Everything that walks, crawls, swims, or flies on the face of this earth can make fever. Why? I mean, it's adaptive. It's part of our immune response. And the reason is your body works better, your immune system works better at a higher temperature. I mean, in the case of COVID-19, these cells, which make antibodies, work more efficiently at a higher temperature than normal body temperature. But you pay a metabolic price for that, which is why your body only revs up its immune system when it needs to. So when there's study after study showing that when you treat fever, you can prolong and worsen illness. So don't treat fever. I mean, the Minister of Health in France steps up and says regarding COVID-19, don't use NSAIDs like ibuprofen, use acetaminophen, Tylenol. Don't use your paracetamol. Don't use either is the answer. Because you need fever. Fever helps your immune system work better. When you give anti-fever medicines around vaccines, you have a lower immune response to those vaccines. It's one of the stupidest things we do in medicine, actually, is treating fever. But it's so culturally ingrained that I don't think this book is going to make everybody stop treating fever. I think that aspirin and Tylenol and ibuprofen are still going to sell well, even though I'm going to publish this book that says don't do it. Another example is don't finish the antibiotic course. There's now abundant evidence and advisory panels now that are saying, really treat till you're better. And once you feel better, you can stop. This whole business of finishing the course, why do we do that? When you have asthma, you treat until you don't wheeze anymore. When you have pain, you treat till you don't have pain anymore. Why do you say treat 10 days for an ear infection when you know that your child who's over 2 years of age and can tell you whether or not their ear hurts, who feels better, stop the antibiotic. Now you can do that. And that's what these advisory panels are recommending, but somehow doctors just haven't gotten the message yet.
That's quite interesting because even in medical school, I'm at medical school in Leeds. I remember learning in our course, we were taught like with antibiotics, take the full course because of fear of bacterial resistance and all of this. So is that not valid?
It's not only it's not valid, it's exactly wrong. In other words, not shockingly, the longer you treat with an antibiotic, the more likely you are to develop resistance. That comes from the time when we first made antibiotics, like in the 40s and 50s, and the doses that were given were too low. So what ended up happening is you would treat, but it was with doses that weren't high enough, or antibiotics that weren't broad enough, and then you would stop, and then the disease would come back because you hadn't really effectively eliminated all the pathogenic bacteria. We're well beyond that. We can do that. So that's why based on all these studies, advisory panels have changed. So get that book and bring it to your professors and say, here are all the studies that show that you're wrong. What are you teaching me?
I did get a low grade.
I'm actually shocked. I had no idea. Absolutely no idea.
Our lives has been a lie. So, for example, I've just recovered from glandular fever recently, and it took me It took me 6.
Infectious mono.
But yes,
exactly.
Epstein-Barr is the,
right.
And there is no vaccine for it. So I'm looking forward to the scientific developments on that. But basically, I took a lot of ibuprofen in that time, and now I'm thinking, could it be that the reason it took me so long to recover one of the factors was the fact that I was trying to fight off the fever.
Yes, that's right. So you made a mistake. Here, I'll give you an example. Okay, you'll appreciate this. So I was on service. This was in the last 6 months or so. So there was a boy who was a soccer player. He was hitting his hip with a soccer ball. He ended up having this septic thrombophlebitis. So he had basically a clot in his vein that then was contaminated with bacteria, specifically MRSA, right? Methicillin-resistant Staph aureus. So we treated him with vancomycin. That bacteria, we couldn't clear it from his blood. He eventually had lung abscesses, he had brain abscesses, he had bone and joint abscesses, and every day, every 2 hours, we were rotating ibuprofen and Tylenol, your acetaminophen, paracetamol in England. And every day he had high spiky fevers, and we kept trying to keep his fever down, and every day for almost 2 weeks he had bacteria in his bloodstream. So finally I sat down with the parents, sat down with the child, sat down with the nurses, and said, let him have fever. Let him have his fever. And within a day and a half, the bacteria cleared from his bloodstream. Now, that may have happened anyway. I mean, that may have just been coincidence. But you certainly couldn't convince the parents of that. They thought we were geniuses. And I do think, you have to remember fever does work for you. I mean, doesn't it make sense? I mean, God didn't invent aspirin makers. God invented fever, if you believe in aspirin. I actually don't. But,
evolution.
Yeah, evolution. Right?
Either way.
Yeah, either way.
That's interesting.
And
I guess also in old age you see it a lot with this over-medicating people, overkill of medicine. Like you see, you go onto an elderly care ward, for example, and there's old people, and it's like the concern is not about enhancing their quality of life. It's more to do with, making them live as long as possible. And as a result of that, they're on 50 medication, and the effect it's probably having on their quality of life probably far outweighs the benefit of elongating their lives. So maybe just take them off all of those medication and just allow them to have a better quality of life, be it shorter. It's like we have this fixation on living for as long as possible as well, which I think maybe is the problem. I don't know if you have anything.
No, I agree. I agree. I mean, I'm an older person, so I can say that. Although this does remind me of that movie Wild in the Streets, where nobody got to live.
Oh, yeah. I'll stop talking then.
Let me shut the door. My dog just opened the door, so let me shut the door. I'll be right back. Don't go away.
Oh, no, it's all good. Thank you.
Man, our
I've got
lives
something
have
in my
been a
eyes.
lie.
That's a good time. Say again?
Our lives have been a lie.
They actually have.
I actually have a lot to say. So, oh yeah, and there is a psychic story in your book apparently. Would you like to tell us about that? The psychic.
The psychic story. Yeah. The point of that story was that the courts are not a place to determine scientific truths. That was basically the point, that scientific truth should be determined in a scientific venue, not in a courtroom. But the story was that there was a psychic who had a headache. She went to Temple University School of Medicine, saw a neurologist there, and the neurologist, as part of his workup, did a CT scan of her head, after which she claimed to have lost her psychic powers. And therefore lost the source of revenue because she was actually worked for the police department, which is actually the most depressing part of the story. So then what ended up happening was she sued. She sued Temple University, she sued the neurologist because now she'd lost her psychic powers because they had put her in the CT scan. So that went to court, where she proceeded to win the initial verdict of $2.5 million. The verdict the amount was lessened, but the verdict stood. So in order for the jury to come to that conclusion, they had to, one, believe that people had psychic powers to lose, two, that they could lose in their CT scan, and three, that the neurologist should have known better than to get a CT scan on a psychic.
The story is disturbing on many levels.
That's crazy.
And what year are we talking about?
This was in the 90s, in the 1990s.
Wow.
1990s.
Although I think if I was the defense lawyer, I would have argued that she should have seen it coming.
Oh yeah, actually, that's a good one.
With the psychic, after all.
It's even concerning that the police department had recruited her.
They must have been a really bad police department, clutching at straws.
Yeah, and is that still the case in that? So for example, if I say, after I went to the CT scan, now I can hear voices in my head, can I sue the doctor still? Is that still?
Well, you're better off coming to America to do it. Here we have the bar is much lower. See, there in England, the loser pays. Here, the loser doesn't pay. So
wow.
Yeah,
Wow.
I see.
And do you have another book in the writing I think you have another book in the writing that will come in the future.
Yeah, I'm working on a book called The Learning Curve.
The Learning Curve, right.
Basically, the human cost behind medical advances. But there's always a cost to pay for breakthroughs. I think it's called the working subtitle is the human cost of medical breakthroughs, or something like that. But The Learning Curve is the title.
And I mean, obviously, you're blowing our minds up with each of your books. Do you know when? Do you have any idea when that will be published?
I haven't even tried to get a publisher
Oh,
yet.
really?
So.
Can we get you on when it's published to talk about it?
Well, I'm happy to do it.
Excited.
Perfect. Thank you very much, Professor.
Yeah, that's everything. We'll let you escape now. Thanks so much for your time. That was really enlightening.
Shad, thank you very much. Good luck.
Amazing.
In your career, both of you.
You as well. Thank you very much. So, what did you think, man?
Bro, it was right. First of all, it was a very interesting interview on from many different aspects. One was that I did research on the questions I asked in advance, so I was expecting what sort of answers I wanted to hear, but turns out for example, regarding the vaccine thing, like literally, I challenge you guys watching this, listening to this, go look at, like, my source of news was Guardian, but obviously feel free to look wherever else you want. If you say, oh, how long it's going to take, they've interviewed they're experts, and it says 2 years, and what they don't tell you, here's what the things they don't tell you on the news. Because basically their idea is they want to catch you, they want to say, oh, coronavirus coming, they want to keep you. So on average, it takes about 20 years to develop a vaccine.
Yeah,
so
that's crazy.
So on average, it takes 20 years. And minimum, as we had Professor Offit estimating, it will be around 5 years, and it seems reasonable if the shortest recorded vaccine in the history has been 4 years. This is like literally, you don't find it anywhere on the news. I did a lot of research, but
it's crazy how much misinformation there is that is spread through media.
I don't think it's I think it's just. Do you think it's misinformation, or do you think they just want to put the headline on to get the money? I don't know.
I mean, I think, yeah, their intention is to put the headline on to get the money, to get the views, but the side effect of that is the misinformation that they're spreading. Like he was talking about, like the MMR scandal that happened and anti-vax movement.
Yeah, exactly.
It's misinformation which is stemmed from people wanting to get views, and it goes into so many more elements of the media than just medicine and vaccination. It's in every element of the news.
Yeah, we can get to other elements later.
Other information.
100%. Yeah. In other words, right, here's what we found today. Media is responsible for killing babies. There we go. Just gonna put it out there. It's actually, it's semi-funny, but it's true.
It's terrifying. It's terrifying. It's what it is, man. The other thing that really shocked me was, with regards to, where is it now? I think I wrote it down somewhere. When he was talking, so he mentioned about, within medicine as well, antibiotics, and like, you don't give the full course of medication. You just stop when you feel better. That's literally in contradiction to everything I've learned about antibiotics so far. Maybe I'm ignorant, maybe I've been mishearing what the lecturers have said, but you're meant to take the full course. You're not meant to stop prematurely, because otherwise bacteria can mutate and cause new infections like MRSA. I thought the whole point was you don't stop giving the course of antibiotic, but he's come on and he said you do the exact opposite. And that just goes to show, like, people lag so far behind scientific discovery, and like society lags behind so far. They say change happens on a generational level. You can't make people who are set in their ways or set in their mentalities to change. Like, it just doesn't happen. You need to wait for the new generation to come through, and with that change comes.
And the same with fever. So in fever, when you go to hospital, they will give you ibuprofen. If you have fever, they'll give you ibuprofen. That's like straight away, just fever, ibuprofen. And I had another friend of mine. He got glandular fever as well. he recovered within a couple of weeks. And his thing was he didn't go to a hospital. He stayed at home. Like he was in fever for like he was suffering and in pain for like 3 or 4 days. But after that, he fully recovered, and it took me 6 months. I actually, right, by the way, guys, anecdotal evidence though, obviously. But, I mean, so Professor Offit has looked at papers, obviously. The fact, what he's saying is based on actual research. But even looking at my own viral disease, it seemed to be maybe that because I was taking ibuprofens constantly for like 2 months, and maybe if I let the fever play out, I might have recovered much quicker.
That's the thing, though, man. Over medicalization is real. We rely on it so much. Like we're lucky to have all these resources, all these medications that we can take, but society as a whole has become so reliant upon them that we forget that the human body is, whether you believe in God or you believe in evolution, whatever the case is, the undisputable fact is that the human body is a masterpiece, and it has so many natural measures in place to overcome things, but people become so reliant upon medication that they just kind of ignore this element of the human body, being able to do these things, having this potential. And it's like when people realize the potential that we have as human beings with diet, exercise, proactive measures that we can take, or just resting and natural healing, getting a good night's sleep.
Yeah.
We overlook them so much and just try and see a pharmacological replacement for them. And it's 100%. A problem.
100%.
The one about sleep's interesting as well. Sorry, go ahead.
Go for it. Go for it. I interrupted you a lot last, so you can go ahead. This one.
I didn't notice, man. Honestly. Yeah, I was just going to say the thing about sleeping as well. We want to talk about sleep in the future. It's so important. There's a book, Why We Sleep by Matthew Walker, which I recommend to everyone. And it just kind of goes through how sleep and just going to sleep every night and getting 8 hours of sleep is so important and so vital to our health and well-being. And not doing that and becoming sleep deprived chronically can have so many detrimental effects on every part of the body, every body system, the mind, the heart, the lungs, just your joints. Everything can be affected by poor sleep. So yeah, it's a very interesting topic, and it's a good book. But society it's not built around our well-being and us getting a good night's sleep. If you think about it, people sleep like 4 hours a night, 5 hours a night just to make it to work on time. And good employees are the ones who get to work early in the morning and leave late at night. The ones who dedicate everything to the company, they're the ones who are doing a good job, and they're the hard workers. But in reality, it's the other way around, If you get a good night's sleep, you'll be more productive, you'll be mentally sharper, and you'll get a better day's work done at the end of the day. But I'm going a bit off topic.
No. This will be one of our future episodes, hopefully, if we can get. What's his name?
We'll get Matthew Walker. We'll get him to come on.
We'll get him on. Well, of course, he'd love to come on.
Best-selling author Matthew Walker.
There we go. Shout out to Matthew Walker.
Yeah, shout out.
So here's one thing I wanted to say regarding the over-medication that you were talking about. I think it can get especially dangerous when it comes to so for example with physical health, right? Because we do have, especially where I come from, we do have people who do not who are actually who are afraid of doctor. They won't go to a doctor under any circumstance.
Really?
Yeah, that's how my granddad lost his life. It was before I was born, but basically he had kidney stone, and back then they couldn't use ultrasound to get rid of it to make not kidney stone. Sorry, no. It was, I think,
bladder stone.
Yeah. One of I'm not actually sure. I'll have to double check later. No. I think it's kidney stone. Never mind. I think it's kidney stone. Yeah.
Yeah. So you use ultrasound.
Pardon?
You can use. You can
use ultrasound for kidney stone, can't you?
Yeah. Break them down with the vibration.
Yeah. So back then we didn't have ultrasound in Iran, anyways. Maybe they had it. So he had to do an actual surgery. But he would never do, he would never go to even, he hadn't gone to doctor his whole life. And when he got really bad, he agreed to doctor, but he refused to do surgery because he was worried, he might die, but then he died because of not doing the surgery. So I think,
really,
yeah. So I think, if I were to tell you, okay, always try to medicate yourself as opposed to never medicate yourself, I'd be lenient on the medicate yourself side.
Yeah, there's a balance.
Yeah, I mean, if you do the right medicine, assuming you don't use antibiotics for viral disease, but I would be like, okay, if you're to be on either extreme, be on the I'm always going to use medicine extreme as opposed to. I'm never going to go to the doctor.
But I mean, if you're talking about the extremes, though.
Yeah, we're talking about extremes.
Go on, you go.
Yeah, because we're talking about extremes. By the way, don't self-medicate. Obviously, don't do that. But if you're to you get a small cold, you want to go to the doctor. Okay, go for it. But it's better than if you're never going to that. Okay, we're just doing very extreme. But I think it can be especially dangerous, this whole over medication, with when people with mental problems, I think, because for example, we have antidepressants, and I think
that's a big topic.
Pardon?
That's a very, very, very big topic. Yeah,
that is a very big topic. But I think essentially, a lot of people, they want to say, okay, or with drugs or with recreational drugs. So they go, okay, I'm feeling low, I'm feeling sad, I'm feeling depressed. What can I put into my system to get me feeling good? As opposed to
if you're pursuing any kind of chemical, feel better solution, like chemical high, talking more with regards to recreational drugs, in this sense.
Even
when you're pursuing that kind of thing, you're gonna, every high's got to come down, and when you come down, you're just gonna feel worse off, and you're gonna want more. I think mental health and medication, it's a more difficult issue. It's a more difficult balance, because especially today, in today's society, a lot more people are on mental health medication. But even with mental health medication, antidepressants, for example, that's not usually first line. Usually they recommend some degree of cognitive behavioral therapy. So you do the lifestyle interventions and approaches first. So if you go to a GP and you've got problems with, poor mental health, I'm feeling down and depressed, lifestyle intervention comes first. So trying to be proactive about it would come before medicated. But I think a lot of people, there's another problem with people getting, they've got mates who take medication and they borrow it from them and self-medicate in that way. And that becomes a big problem as well. Problems everywhere.
Indeed. And I think also, for example, other forms of addiction that are not technically chemical addiction, but in practice, they become, for example, sugar addiction, food addiction, gaming addiction. They become you do that to get you that chemical high in your brain.
Dopamine rush.
Well, the chemical rush. No. Well, yeah, you don't get high on sugars, do you?
You can. I mean, the dopamine cycle, it feeds all addictive behavior. So the dopamine that's released in anticipation of something that's going to feel good. So it could be anything. Food, gaming, like you're saying, drugs, and it's the dopamine starts rising when you think about it, and it keeps rising and it keeps rising, and you chase that feeling of the dopamine getting elevated and becoming raised, and then you do whatever it is that you wanted to do, and then after it's done, inevitably you'll feel low again, or you'll feel back to your baseline, and when you're back there, you want more dopamine, and as you feed into that cycle, the sensitivity to dopamine rises as well. So if initially you'd have one biscuit and you'd feel satisfied, after a month or a year of compulsive eating biscuits, you're going to want 50. You're going to want, 10, 20, 30, 40, 50 biscuits before you get that satisfaction or that feeling
build up tolerance.
Exactly, yeah. And it can be to anything. It doesn't have to be, drugs and hardcore stuff like that. It can be to anything. I forget why this is relevant.
This is, well, speaking of overkill, when you're looking for chemicals to be fair, we made quite a bit of jump there from chemicals to food addiction. But there we go. That's why you guys listen to us.
As unpredictable as, the future of coronavirus, which, the professor said was very difficult to predict. Will it become endemic? Will it not?
Oh yeah, that one was an interesting one.
Will it not? Who knows?
He doesn't think it will become an endemic though. He was on the side of it won't, because it's not mutating fast enough. Yeah, that's
no though. I didn't. That's not what I took from what he said.
Really?
I thought maybe it was. I don't know. I guess it's open to
interpretation. Time will tell. Only time will tell.
Time will tell. We'll have to wait and see. I mean, I hope it doesn't.
Well, we'll see. Which other questions was there that I thought was interesting? I was really interested with the microscope one. So if you have a virus, you look at it under the microscope, you can't really tell what it's gonna do once inside the body. You can't tell. Because like as a sort of outsider, that's interesting to me. That so you make vaccines, you study the virus. If you look at it in the apps outside the body, you have no idea what it's gonna do once it's inside. Or
I guess
whether or not it will kill you or not, how dangerous it is, you can't tell by looking at it. It's weird for me. It's weird to me that if you look at it.
It's weird to me as well. It's weird to me as well when you put it like that. There's a lot of uncertainty there. It is weird.
But that's kind of comfort. Well, I mean, he got us worrying at the end, that saying, oh, it is possible to engineer some virus. But it means, like, for example, let's say, okay, this means since we can't tell what it does, then surely this ruins all conspiracies. We can't create a virus and tell it. We can't, like, it's not like a computer code, like, do that, like a virus that eradicates all humanity. Ding ding. And then the machine gives you the virus. And then
that's the thing, though. In a way you can, really? Because we already have. Think about it. We have the deadly viruses, like we have rabies, for example. Like you were saying, the thing is, that, and Ebola, we have the deadly viruses. The issue is transmission of those viruses. It's like not an issue. The good thing about rabies, for example, is it's not airborne. So like you can't breathe in rabies and then just acquire it. So bioterrorism and people who want to cause harm with viruses, all they need to do is change the mechanism of transmission of dangerous viruses. So they don't need to make anything new. They can take something that's already dangerous and just make it more dangerous by making it more transmissible. So like, I guess there is still that fear. But like you're saying, it's not you can't.
It's not easy. At least it's not easy. There we go. That's one thing to take comfort in.
This is true. There's another film. He mentioned Contagion. There's one called Quarantine as well. A horror film. I watched it when I was really young, and it gave me nightmares for a long time. I think that's about some mutated form of rabies. So there's a lot of films about bioterrorism and changing up common viruses to make them more dangerous. Hopefully no one gets any ideas.
Wait, well, I mean, to be fair, if you get idea by watching this podcast or listening to it, more likely, we take no responsibility, and also
we're ignorant.
It's a surprise you haven't come up with it early. You had to listen to this podcast to get the idea. You evil.
Yeah, I mean, in a way, it's impressive that we had that that much of an influence on someone. I would take.
To be fair, I might take credit for it. Not gonna lie. If someone goes, my inspiration was Little Brain, Big Topics. I go, okay, you know what?
Shout out.
At least he's not a plagiarist.
Oh man, I think that's a good note to kind of wrap things up on.
Alright, we want to wrap things up.
Anything else you want to add?
Don't worry about it. Don't worry. Well, we'll have plenty of time to talk about other things in future podcasts.
Yeah, so thanks very much, guys, for listening. If you made it this far, which is unlikely, it's probably two of you right now who sat down.
We know the two. Oh, actually, okay.
But
okay,
yeah,
no,
lots more to come.
Let's
Hopefully in the
put
future.
something. If
And
you've stayed till this late, give us put in the comment that I stayed till the end, and then we'll I don't know. We'll do something nice for you. We'll shout your name out in the next podcast. There we go.
we'll bake you something as well, like a cookie.
Yeah, we'll bake a cookie in your name. So
and
put in
eat
the
it on
comment section if it's on Facebook, YouTube, Instagram it won't be on. So Facebook or YouTube. If you've stayed till the end, write your name down. We'll give you a shout out. Okay, guys. So just to end our podcast, we have Twitter now. So Little Brains Big Topics. I think we're at big_topics. We have Twitter now. Make sure to follow us on Twitter. We have Instagram, Facebook, YouTube. We're on iTunes, Spotify. Make sure to follow us everywhere. Share, comment, everything, guys. Everything. Please, if you enjoyed what you saw, please make sure to support us. We love you all. Yeah. Take care, guys. And let's show our ending sign of heart. Okay. That's it. Let's end it.